Yeah, no questions.
Okay, no questions, right? Okay, I'm sharing my screen. I got the point. I'm closing this. Can you able to see my screen?
Yes.
Yeah.
Yeah, thank you. Thank you. Thanks for that. Let me log in into my AWS account. Do you people created AWS accounts?
I mean, I have a Docker in my local, so I'll be using from local.
Yeah, no problem with that. Yeah. Chances.
The installation steps for Docker that we have provided, that will work for only Ubuntu VMs or any flavor of Linux it will work. Like
Yeah, these are which I have shared to the in the comment in the comment that will be working for Ubuntu. And if you want any different version, if different operating system installation, you can go to Docker installation page. So you can follow the steps here, which platform you want to run.
Mm-hmm.
Those will work only for Ubuntu. For Ubuntu, which I'm using, I have fetched that commands, and I have shown you that.
Okay.
Yeah, and yeah, Docker, I will be connecting, or let me show you the other way. SSH client. Click on this SSH client. Copy this example. Go to this terminal. Here is my key as stored. Let me see that. AWS. Yeah. pwd cd documents ls cd aws ls. Okay, command v. Stored my key not here. Maybe in the downloads.
Will be by default in the downloads folder.
But some of the keys I moved to this folder. I thought that here itself I moved, but might be you're right. By default it's downloads. pwd downloads. Or if it's not connecting from here, I will connect from there itself. Mostly it will connect it. No permissions denied. Okay, ls-la. There is DurgaSoft. Okay, ls-la.
There is DurgaSoft.
DurgaSoft.pem, this is a file name, right? We need to
Yes.
change the permissions actually. See, if you see here, user has, I have only read and write permissions. You need to also give the execute permissions actually. So for that, chmod
755.
700, I can give that, or 744.
You can give 777.
777 is a full access.
Full
I
access.
don't
Full access,
want to
yeah.
give to
Anyway, it's
other
popular.
users. Yeah, I don't want to give that. Okay. This private key will be ignored. DurgaSoft.in bad permissions. Okay, permission denied, public key. It is required that private key files are not accessible by others. Okay, 744 for DurgaSoft are to open. Okay.
700.
Yeah, let me try that. Yeah, it has been connected. Clear. Thanks for that. I will be switching to sudo su hyphen. Okay, let me see my Docker is running or not. Uh, uh, okay, let me see my Docker is running or not. Systemctl status Docker. You can see it here. It's active and in running state from past 23 hours ago. Yesterday we have installed, right? That's the one. Okay, Control Z or
How can
yeah,
we check in Windows?
Windows. Okay, you can just run Docker in the command prompt. Okay,
Okay.
like I'll show you.
Docker status.
Just run Docker and then enter.
Yeah, I mean, it's giving the helping commands. So
Yes, that means your Docker is properly running.
no, I mean, we need to give an option, right? Docker status. Yeah.
No, you can give if you want to check version, Docker version. But you see, if that is giving the status like options, that means it is properly running inside your machine. Maybe there may be other commands also in Windows, but I'm not sure. Let me check the other commands which we need to check the Docker is been properly running or not. Or you can see in Windows. I hope when I'm using in my starting stages, there is something called all the applications which are running. There will be showing in one application, like it's something called Control Panel or something. There what are the applications are running, how much amount of CPU and memory will be using that applications. There we can see actually if your Docker is there, then your Docker is properly running. I can say you this one also. And if you want any command, I need to check actually what is a command for Windows in order to check whether the Docker is properly running or not on Windows. So yeah, that is the thing. Okay, Docker is, as you see, Docker is running properly. Suppose before discussing about the Docker architecture, I want to show you how we type command and after showing how we execute the commands, and then I want to show you the Docker architecture. If I show you first executing the command, then you will be properly understanding the Docker architecture. This is my strategy. I hope so. It will be working out actually. So suppose if you want to run any application, okay, not only Nginx, any application, we need to download the first binary or image, Docker image from the Docker Hub or any of the Docker registries. We have multiple Docker registries, but we will be using the Docker Hub. By default, it is the Docker Hub. Yeah. So let's check the Docker Hub. Okay. hub.docker.com. hub.docker.com. And I recommend to create an account here as well. Click on sign up. Okay. And give your credentials here or email, username and password. Just sign up. Okay. And you will be having your private account. Okay. Then if you want to go to public, click on explore. Then click on Nginx. So these are all the images that we have as a public images, okay, in the hub.docker.com. But I want to show you by running this application as of now, because it's a starting day of Docker. I will be showing you how to run this application, okay, in the Docker in your EC2 machine, okay, actually. So first, let me check whether any of the images are there in this Ubuntu machine or not. Okay, Docker images. No images are there. No images are there. What are images? Images are the binaries or files or whatever it is. That is, they are used to run the applications. That are images actually. No images are there in our laptop as of now. We need an image to pull to run an application. Okay, that means we need to download an image from the internet or hub.docker.com. To do that, Docker pull, and if you want to download, let me take an example of Nginx only. Nginx. Okay, just this is a command. Anyway, I will be providing the clear documentation about it. Okay. Okay, in Docker actually, these are something called layers. I will be clearly discussing with you what are these layers in the upcoming sessions. Okay, and how these are used in other Docker images. So I'll be clearly discussing with this. Okay, and as of now, to make it running application, just whether the Docker image is there or not, we have downloaded, but whether it is there or not, let us check that. Docker images. So we have downloaded this image. This is a image and this is a tag. Okay, and this is a created date. Actually, this date is something that is pushed to the hub.docker.com. Actually, 2 weeks ago it has been pushed, and its size, this size of this image is 187 MB. Someone has something in the chat. Okay, okay, this is the size of the image, actually size of the Nginx image. Okay, this is a size. Okay, now image has been downloaded. Suppose I will I want to run this application. Docker run. We have some commands in the Docker run -name is equal to whatever name you want to give, my app. Okay, then I will be explaining after running this command what are these flags. -d -p 80:80. What is this meaning also I will explain, no problem with that. And what is the image? At last we need to give an image. This is a image name. Okay, Nginx. Okay, so I will be running this. So our image has been successfully run. Okay, our image has been successfully run as an application. Let's check that. Docker container. This is another command to check running containers. What is container? I have already told you in the demo sessions previously. Container is something which inside which our application will be running. That is container. Okay, Docker container ls. Okay, see, this is container. In which our application will be running actually. Okay, this is the container actually. This is our application. Okay, container ID. Suppose this is the container. I want to access from my web browser. Suppose this is a container I want to access from my web browser. Let me check that whether I'm able to access or not. Okay, let me take the public IP order of the machine instances. Docker public, just copy this public IP address, go to the new tab, Control V, give 80 port number. Why I'm giving 80 port number, I will be clearly discussing in the diagram. Okay, see, this is the Nginx application that is coming from my machine actually, that is running inside my machine as a Docker container, and I am able to access this application from my web browser. Okay, through this machine IP address. Okay, with port 80 port number. Okay, what is that? What are the flags that we have entered there? Let us check that. Okay, What are these flags? What is -d? It means detached mode. Detached mode. I'll be showing that before I'll explaining this. What is this -p? 80:80. Okay, what is that actually? Let me take an paint. Where is that? This one. Yeah, I will be taking this screenshot. Okay. Okay. I have told you yesterday. Okay, this is our machine, virtual machine that we have discussed. Okay, this is our EC2 machine. That means virtual machine. Okay, then I'll be writing it as here EC2. EC2 machine. Okay, our machine has ports within that ranges from, okay, port ranges from 0 to 65,565. Okay, let me expand this. 0 to 65,565 ports actually. That what are ports? This application, this machine has ports. Like I'll be drawing the diagram here like this, through which we can connect to the applications inside, running inside this machine actually. Okay, like this, like that. 65,565 ports will be there. Okay. Okay, these are the ports like that. 65,565 ports are there. What we have done? Okay, we have installed Docker in this machine. We have, sorry, this is not the right diagram. I can say I'll take this. We have installed Docker in this machine. Actually, DOCKER. We install Docker in this machine, and then what we have done is we have ran the Nginx application, Nginx container. We have run the Nginx container upon this Docker Nginx container upon this Docker. This Nginx container, inside this, what will be there? An application that will be running inside this Nginx container actually. That is Nginx application. Upon each and every application, whether it is Java, whether it is any language, each and every application that will be running on specific port number. Like that, Nginx will be running on port 80. Okay, I'll be placing that here. I'll be taking this. Okay, and let me take this. So okay, this is the port 80 in which our application, Nginx application, will be running. This is a port number in which our Nginx application will be running. Okay, suppose this is our browser. Okay, this is our browser. Oh, that is also gone. Okay. This is our Chrome browser. Okay, we have put public IP of machine colon 80 port number. Okay, public IP of machine colon 80 port number in our new tab, right? So we are able to see the Nginx. We are able to see the Nginx web page. Nginx application we are able to view here in the browser like this. We have seen, right? That one is the Nginx application. How we are able to see? How we are able to see? What is the meaning of that -p which I have used? What is the meaning of this -p which I have used in this command -p 80 colon 80? What is its meaning actually? What is its meaning? Let me tell you that in the diagram. What is its meaning is, okay, suppose let me take the text. Okay, let's assume this machine has, as I already told you, this machine has 65,000 0 to 65,565 ports. Ports will be there to that machine, that many number of ports. And suppose let's think this port has 80. This port one, this is 80. Okay, this port has 80. This port is 80. Now -p that we have written in our command 80 colon 80 means -p 80 colon 80 means this 80 we are mapping to this 80. Container IP port we are mapping to machine IP port. Any questions up to here? Did you understand, or shall I explain one more time?
Can you please repeat again?
Okay, yeah. What is the thing is, okay, what is the thing is, our application inside the container will be running on 80 port. Nginx application will be running on port number 80. Okay, in order to access our application from the web browser, you need to map these ports actually like this. Okay, that is the meaning of -p 8080. If we when you are running the command, docker command, if you give -p 8080, that the meaning is container port upon which our application is running will be mapped to machine port of 80. Okay, now public IP of the machine, this machine, and colon 80 means our web browser will be connected to this 80, and this 80 port is connected to container port 80. Then you are able to access the application from your web browser. You get that?
Nginx port is 80. The VM port changes it from 80 to something else, 60 or 100, so that it will be easier to understand. 80
Okay.
is a bit confusing.
Okay. Let me change that. So clear. Okay, 1 second. I'll clear this. Oh, this session has been expired. Okay, let me log in there itself. Connect. Instance connect. Okay. Sudo su hyphen docker container ls. This is the docker container which is running. Let me stop this docker. Let me delete this docker container. For that, the command is docker rm. This is the running container I want to delete. Let me close this first. And this is a running container I want to delete. Actually, if you want to delete the running container, you need to use this command docker rm -force and the container ID. So Let me check whether the container has been deleted properly. Docker container ls. So the container has been deleted properly. The container has been deleted properly. Now what I'll do, I'll again run the Docker, but the image will not be deleted. We are only deleted the container, but not the image. Let me check that. I'll show you that. Docker images, Nginx image is already there. Nginx image is there. We are only deleted the Docker container here, but not the image. Okay. Docker. Let me clear the screen. That will be clear. Docker run hyphen name. My app. I have given my name -d detached mode -p 80 not. I'll be giving 80 port number, or I'll be giving 9090. Not to be clear, 1990:80, and Nginx. So whether my Docker container is properly running or not. Docker container ls-a, right? So my Docker container is properly running now. My Docker container is properly running now. And now in our diagram, few things changes now. Now I have changed this 80 port to 1990. This 80 port. This is the machine port. I will change it to 9090. 9090. Let me. Okay. Now my application is connecting to different port 1990, and when I type from my web browser, what is the IP address of this machine public IP? Just copy this public IP and go it here and paste this public IP. Click 9090, enter. You are able to see Nginx application. What is the changes that I have done here? Okay, let me show you that. Okay, this my application, my public IP, my web browser is connecting to 9090 port of the machine. 9090 port of the machine, and this 9090, because of this -p option we have given, -p 9090:80, because of this option we have given in the command, this communication is happening actually. So this 9090 has been mapped to 80 because of this -p 9090:80 actually. This is the way, that is why you are able to access that application from the web browser actually. Okay, you are requesting with the public IP :9. Sorry, this is also changed. Let me change this 80. This has changed to 90, right? Public :9090. Okay, I'm accessing public IP of the machine :9090. That means your request will go to machine port number 9090. Okay, then because of this -p option, this 9090 port number has been mapped to 80 port number of the container. On this 80 port number of the container, Nginx application is running. That's why you are able to view the application in your web page. Any questions, please, here?
Good. No questions.
No questions, right? Did you understand, right? Yeah. That is why you are able to access your application in your web browser. Okay. This is the Nginx application you are accessing. Okay. Now let me close this. Clear. Now, the next command I will be showing docker container ls. So this is the container Nginx container that is running, which we have just run actually. Okay. Then if you want to remove the container, what is the command we have used? Docker docker rm -- force is equal and container id we have used to remove the running container. To remove the running container, we will be using -- force option, -- force option. But if you in the real time, actually we will not be removing the running container. First, what we'll be doing is we will be stopping that container stop, but most of the cases this will not happen. We will not stop the container, but if that requirement has come, you should first stop the container before removing directly, like by using -- force. Okay. Docker stop this container id you need to give and click on enter. This container will be stopped. This application will be stopped running. Okay. Now let's verify that docker container ls, docker container ls. That means any application is not running in your in by the docker as a container. Any application is not running as a container. Okay. If you want to see any docker stopped containers as well, docker container ls -a is means all running containers and stopped containers. Okay. See, if we don't use -a in this command, the stopped container is not shown. Okay. But if we use -a in this command, the stopped container are also shown with the status exited. Okay. That means we have stopped, right? But again, in order to remove this container, docker rm container id. You should not use force here to remove the stopped container. Okay, that has been removed. Let's verify that. Docker container ls -a. See, now stopped container also not there. So because we have removed the stopped container. Okay, now any application is not running actually. That is the case. Now these are few commands before discussing the Docker architecture. Now let's discuss the Docker architecture actually. Okay. I hope you got what is difference between Docker client, Docker host, and Docker registry. Let me revise you once again. What is Docker client? Docker client is a command prompt from where you are executing Docker commands. Okay, from where you are executing Docker commands. And Docker host is upon which machine the Docker has been installed, that is Docker host. Now in our case, Docker client and the Docker host both are same, the EC2 machine. Okay. And what is Docker registry? Docker registry is the it's a registry, it's a storage where application images are stored, like images are stored hub.doc, like hub.docker.com. Okay, then I'll be explaining the Docker architecture. Clear? Where is that? Okay, let me take this screenshot and forward you in document. And I will select this. Delete. Okay. What is Docker architecture? Okay. Now let's take an Docker client. This is let's just imagine this is Docker client. This is Docker client. Oh, why it has come second one? Docker client. This is Docker client. Okay. Then from the Docker Docker client. From the Docker client, what command we have issued? First command what we have issued is docker pull nginx. Docker pull nginx, right? First command we have issued docker pull nginx from the Docker client. Okay, what this command actually did in the background? What this command actually did in the background? Okay, I have shown you, like I have shown you a background process is running. Docker is running in the background as a daemon. We'll call daemon. That is called daemon in the operating system language. Okay, so whenever you type any Docker command, from the Docker client, a daemon will be listening on the Docker host. Let's imagine this is Docker host, actually. Docker host. Docker host. Let's imagine this is a Docker host. That means our EC2 machine. Okay. So a daemon will be running, a Docker will be running in this Docker host. Okay. Let's take this and I will be pasting it here, or Docker daemon will be running on the Docker host. Whenever you issued, and one more thing is also there. Let's also draw that, and I'll be explain this Docker registry. This is Docker registry, that is hub.docker.com. Okay. This is Docker registry. Okay, whenever you issued this Docker pull nginx, your daemon will be listening that. Actually, your daemon will be listening that. First request will go to your daemon. Like this. Okay, this is the first request, and then daemon will be checking whether the Docker this nginx image is already there or not. Did you observe when first time we have pulled the Docker image in the machine? Docker images, right? Sorry, Docker images. Okay, first time we did Docker pull nginx, and we have run the container, and we have changed our scenario to 90:80, and that time we did not pull the Docker image. That means the Docker image is already there on the machine that we have pulled on the first time. Okay, that is checked by Docker daemon in our diagram. Okay, where is that? Okay, Docker daemon will be listening Docker pull nginx. Our command, this daemon will be listening, and it will be checking in the Docker host whether that image is already there or not. Okay, that image is already there or not. If that image is not there, let us assume this is the first time we are pulling the Docker image. Actually, the Docker image is not there. What this daemon will do? By default, it is connected to Docker hub. This is provided by Docker. This will be pulled from Docker hub. Actually, this will be connecting to Docker hub. And let's take, there is an image nginx on the Docker hub. Nginx image is there, and what it will do, it will download. Docker daemon will be downloading that image on your local Docker, on the Docker host, Docker host. I hope these terminologies is understandable for you. We have yesterday clearly discussed what are this Docker client, Docker host, and Docker registry, okay, and Docker daemon as well. Okay, it will be downloading this Nginx application onto your local machine, that means Docker host, okay, Nginx application onto your machine. Actually Nginx image, that means image, application means image, it will be downloading. Okay, and let's draw this as a diagram. Control Z, I'll take okay, and inside this Nginx application is there. I want to separate this, that's why I want to I have drawn a diagram here, like box Nginx. Okay, it has downloaded Nginx image actually, and when I run docker run command, what command I executed, let me write it here again. Okay, let me write it here again. Docker run hyphen name is equal to my app, okay, hyphen d hyphen p 90:80 and Nginx. This last Nginx called Nginx image name. Okay, this is a command I have run, right? So with this command, what this Docker daemon I have executed, second command is this one. Let me put it here. OCJA Docker run my app hyphen d hyphen p 90:80 Nginx. Okay, I have executed this command as a second command from the Docker client. I have executed. Okay, let me put like this. Okay, this command I have executed as a second command. Now what happened after executing this command? Our Docker client is connected to Docker daemon. Okay, Docker client is telling, hey Docker daemon, please execute. User has been executed, executed this command. Please execute the requested application. Then Docker daemon will be checking whether this Nginx image is there in your local laptop or not, on the Docker host or not, and on the Docker host, Nginx application is there as part of Docker full Nginx, as part of Docker full Nginx. Nginx image is already there, then it will be not connecting to Docker registry. It will be using this Nginx image and run as a container Let's take an example. This is a container. Okay, Nginx container. With the help of this image that is already downloaded, this Nginx container will be running. With who will be running this? Docker daemon will be running. Okay, that is the Docker architecture. Any command you issued from the Docker client, that command will be listened by Docker daemon. That command will be listened by Docker daemon and perform the requested command that you issued. Actually perform the action for the requested command you issued. Actually, let me make the numbers as well. This is the first step number 1, and step number 2 is this, that will be connecting to Docker, and step number 3 is this. Step number 3 is this. That means Docker daemon will be downloading this Nginx application on the Docker host, and this is the downloaded. This is a case of Docker pull, and this is the step number 4 we executed. Step number 4 is this. Step number 4 is this, and then this daemon will also will be connecting to like we'll be checking Nginx application or is there or not. This is also step number 5. Or let me to avoid the confusion, let me draw another line to checking the Nginx application. Let me say this step number 5. This is a step number 6. This is how the Docker architecture is designed actually. This is how the Docker architecture is designed. Okay. Docker architecture. Okay. So any questions here, please? Any questions, please ask. If
No,
not, we'll be continuing further. Yeah.
Okay, fine.
Fine, right? Yeah. Thank you. And then we will be creating some simple custom image. It's not a custom image, I can say. How you can create an image from the existing Docker container. I want to show you that actually. How you can create an image from the existing Docker. Let me tell you what is it clearly. Okay. Clear. I'll be clearing the prompt. Okay. Let me see. Docker container ls, and no container has been running, and Docker images. Let me check that Nginx image is already there. Docker run hyphen name is equal to Nginx. Let me give my app. My app hyphen t 1990 colon 90 or 80. Actually, application will be running on 80. That's why we're given 80. Nginx is the image name. Okay. Docker run -d. Okay. Nginx. Then our application will be running Docker container ls. Our application is running. How to log in into this application, into this container? Actually, this is a container in which our application is running. How to log in, how to get into this container? Let's check that. Okay, let's check that. Okay, let's just copy this container id. Copy this. This is a container id. This is an image we have used. This is a command what I'll showing in the case of custom Docker images. I'll be showing what is created it, status, okay, ports and name. These are the fields which are available, which will be showing when we execute Docker container ls, right? Just copy this container id. Just copy each and every container that we are running will be having some id. Each and every container that we are running will be having some id, that is this container id. Actually, this container id, just copy that, execute this command docker exec docker exec docker exec hyphen it. Why it is not coming? Hyphen it. Okay, then just paste the container id you have copied. Just paste the container id you have copied and just give /bin/sh /bin/sh. That means you want to open the shell of that container. You want to open the shell of that container. This is the Linux one. But this, if you want to open the shell of any machine or container, we have different types of shells. Bash shell is there, sh is there, some other shells are there. Shell means it's a kind of command prompt. It's a command prompt. You want to open the command prompt of the Docker container. That is the meaning /bin/sh actually. So I'll be executing that command, the shell has been opened. We are logged in into the container. In this container, we are logged in into this container. Actually, let's check what are the files or folders present in this contain inside the container. These are all the files present in this. These are all the files present in this container. These are all the files present in this container. Suppose I want to create my own container with the help of this container. Okay, if at this time it will be difficult for you to understand it, but I'll be trying my level best. Okay, just create a file here. Touch is a command that is used to create a file in Linux. Okay, touch is a command that is used to create a file in Linux. Touch, just create execute test. This is a file name that you want to create a file name with. Okay, touch test, then verify whether that file is created or not with the help of ls command. Okay, then you can see it here that test file has been created. But in the case of above, before creating the test file, there is no test file. You can see, right? There is no test file. Then we have created touch test, and the test file has been there. The test file has been there, right? Then I will be coming out of this container. In order to come out of this container, you need to execute exit command. Exit command. Then click just exit. Again, you are back to your EC2 machine. You are back to your EC2 machine. Just verify the container is there or not. Docker container ls. Our container is running. And I want to create a new image out of this container, because I have updated the container by creating file inside that container. I created a test file. I have created a test file so that I want to create a new image, right? So I want to create new image out of this running container. Okay, before running this container, there is no test file. We have manually created this test file inside the container, right? So I want to create an image out of that container. I hope what is an image, okay? It's a binary that is used to run a container. Okay, so I want to create an image out of this running container. To do that, docker commit. This is a command, docker commit, and this is a copy this container ID, and then give the image name that you want to be creating. Okay, I want to give custom Nginx image. That means updated Nginx image. Custom means it's a let's give updated Nginx image. This is the name I want to give to that new image. Then I'll be clicking on enter. Okay, now I'll be verifying this image has been created or not. Docker images. Okay, a custom image has been created. You can see the age created it 7 seconds ago. Just now we have created this custom image. That means updated image we have created. Okay, now I want to run this updated image. Okay, just we will run that. Docker run hyphen name is equal to updated image, updated app, and then hyphen d hyphen p. I'll give 9091 because this which is the container which is already running is running on 9090, but I want to give 9091 : application port is 80, application inside which application, the Docker container inside which the application is running is on the port 80. That's why 80, and I will be giving this image name, actually image name. Okay, I want to run this image. Okay, which the updated image. Okay, we are not running Nginx, right? We are running updated image or updated image. Okay, just keep in mind we are running updated image. Okay, then let's check whether it is properly run. Docker container ls, docker container ls. You can see the new container has been running. Okay, and it's 7 seconds up. Just we have run 7 seconds ago and created 8 seconds ago. Just we have created 8 seconds ago, but it's came into running state 7 seconds ago. Okay, this is the image it is used, and the container ID. Let's log into this container ID. Now just copy this container ID. Docker exec hyphen it. That means what is mean by hyphen it? That means interactive terminal. That means we want to open the terminal of the container. That means command prompt of the container. Okay, then container ID, just give that /bin/sh /bin/sh. Just verify we have given the container ID of the updated image. That is the container ID. We have not given the Nginx image. Just keep an eye on it. This. We have given the image of the updated ID of the updated container, updated image. Okay, updated container. Okay, this is ID and /bin/sh to log in into the container. Just click on enter. We have logged in into the container. Then check the files whether our test is there or not. See, our test is there. Okay, previously when we run the Docker container with Nginx, there is no test file. You can verify here, there is no test file when we run Nginx, like when we created when we logged into that machine, that container, there is no test file, and we have manually created test file using touch, and we have verified whether it has been properly created or not in that Nginx container. And what we did, we have like created an container. We have created an image out of the running container Nginx, like out of this running container, out of this previous container, we have created an updated image, and with this updated image we have run the new container. With the updated image, and we have verified whether the existing file we have created in the previous container is there or not, because from the previous container only we have created an image, custom image, our own image. Then the previous container file which we have created manually should be there in the new container. See, what is the scenario that is there will be there in the real time, when we join in the company. That means this is the first container. We have executed here Docker run. This is the first container Nginx. Okay, we will be installing some softwares inside the container. It's just we have took an example of Nginx, but in the real time we will not take an example of Nginx. We will take different images, but let's assume it says Nginx, and we will be installing different softwares inside that container, and we will be creating a new image out of that container, and we will be executing that new image as another container, so that our software will also, our software which we have installed manually will also be there. That is a scenario that will be happening in real time. Actually, that's why I want to show you this scenario in today's class. This is the one. Any questions up to here, please?
Okay for me.
Yeah. Thanks for that. And today what we have discussed, we have run the Nginx application, and we have accessed from our web browser. Docker architecture also we have discussed, and for creating the custom like updated images also we have discussed, and we have discussed port mappings, and what is -d we'll be discussing later. And yeah, and next thing I want to show you Docker stop. Some commands also we have discussed, like Docker stop, Docker rm force, which is used to stop like remove the running container, Docker Docker rm command, which is used to remove the stopped container, and Docker images, which is used to view the images which is already present on the Docker host. And we have logged, or in order to log in into the Docker container, we have used Docker exec-it command to log in into the Docker container, and we have used Docker commit command in order to create an updated image out of Docker container, And the last command which I want to show you, which I have missed in today's class is, let me show you, Docker images. We have already shown. Let me tell you other command. So Docker images means we have the images that we have in our Docker host. Docker host means our EC2 machine on which the Docker is installed. That is meaning of Docker host. Okay, we have an images. I want to remove these images. To remove that images, we have another command. Docker rm command is used to remove the containers. To remove the images, Docker rmi. Okay, this is remove image. That means rmi means remove image. Okay, Docker remove nginx. I want to remove nginx image. Okay, error, no response, conflict, nginx must force container id. Okay, the meaning why it is unable to remove this nginx, why this command is unable to remove this nginx image is this image has been used by Docker container ls. This image is used by this container is using that image. That is the reason why you are unable to remove this nginx image out of by using this Docker rmi nginx. Okay, let's delete this container. Okay, and test this Docker rmi command. Okay, Docker rm. I will not be encouraging to use -force. I'll be stopping that container, and I'll be using Docker rm command. Okay, Docker rm container id. Okay, that container is removed. Docker container ls-a. Now that nginx container has been removed, and let's see Docker images. The image is ready to delete. Docker rmi nginx. Oh, sorry, Docker rmi, right? I have created Docker rmi nginx. So the nginx image has been removed from my Docker host. Okay, Docker images. Let's verify that. No nginx image is been there. Okay, that means what you got now, if that image is used by any of, if the image on our Docker host is used by any of the container which are running on the Docker host, that image cannot be deleted from the Docker host. Okay, to remove that Docker image, normally we cannot remove that image from the Docker host. To remove that Docker image from the Docker host, you need to remove the container. You need to remove the container which is using the Docker image, and then you need to remove that image. That is a process you need to follow in order to remove a particular image, actually. So these are the things I want to explain. today in the class. Okay. Any questions, please, in today's session? Because like today is the last day for the demo, and from Monday there will be a new link to be joining for the joining, and please go to the Durgasoft website, register there for the course. Okay. Yeah, I want to mention that. And yeah, any questions, please?
Hi.
Yeah.
Sorry, I just joined today.
Okay.
Okay, and can I request for the videos?
Yes, these videos were already uploaded into the YouTube. Okay, demo videos were already uploaded into the YouTube, and then you can go ahead and watch there. Let me share you that videos.
Can you
Let me
please?
stop. Yeah,
And
I'll be. Yeah.
what is the duration of the class?
Duration of the class is between 8 to 9 a.m. morning. Okay, and yeah, if that sometimes it is extendable, like up to 9:15, like that, because we cannot leave some topics in the middle and go right. So sometimes it will be extendable to 15 minutes, like that, but I can say from 8 to 9:15, like that. And the course duration is 40 days, 40 to 45 days. Yeah, both Docker and Kubernetes.
Okay.
Yeah.
So these practicals, everything we'll be doing on AWS cloud.
Yes, that is your option. That is your option. You can use the AWS or you can use your local laptop. But my recommendation is is to use AWS cloud. Okay, because your laptop configuration, not you, some people laptop configuration may be little low. If you install Docker in your laptop, that may affect your laptop. That's why I'm using the EC2 machine. That is your choice. You can use your local machine or the EC2 machine. Anything is fine.
Got you. Yep. Thank you.
Yeah.
Please
Yeah.
share me the YouTube links if possible.
Yeah, I'll be sharing. Please be there in the call. I'll be stop sharing my screen. I'll be sharing that